Alright guys, and welcome to Universe Sandbox2, and as you can see I have made the Kepler 90 system, and NASA actually announced it just 2 days ago, back on Thursday. And they discovered a new planet around this system, which makes this the second 8-planet solar system besides our own. Now, there are quite a few other solar systems that have 2 or more planets, but the Kepler 90 system here is the second solar system to have 8 planets besides our own. Now let's just have a quick look-see at them a bit. Now I made just a moment, let me check something here quickly. Settings. Just want to check something on the volume here. Yes, audio. Okay. That actually helps quite a lot. Not sure if you guys got that, but Kepler 90, besides our own solar system, it's the second one to have 8 planets, a lot like ours. And I created this system from the information that I got so far. So let me just go on chart here, then we can see the star and the planets a bit better. Now Kepler 90 itself is a star, a whitish main sequence star with a mass of 1.2 times the mass of our Sun, and it's just 2 billion years old, so it's still on the main sequence. Now I will talk more about the main sequence in a later video, but in short, it's basically in its not middle life, but it's past the stage of being born. It's now in its slightly later stages after being born from a planetary nebula. Now I will talk more about that a bit later in a later video as well, but it's now in its stable part of its life. Now, with the planets themselves, we are not quite sure on their exact masses, except for the 2 outer planets, Kepler 90G and Kepler 90H. Now, the way astronomers do this is if they discover a planet around a star, it's also called Kepler 90, or it's named after the star that it orbits. In this case, they're all named Kepler 90. However, they also have a smaller letter beside them, as you can see here with this one, for example, over here, Kepler 90G. It's the it's the 7th the 7th planet from Kepler 90, and yeah, that's the case with every planet discovered around their host star. They're named after the star with a letter of the alphabet next to it, usually in the order that they're discovered, if I got that correctly. Now, the only two planets that we have, that we definitely have a mass of, are Kepler 90G and Kepler 90H. Here, Kepler 90G has a mass of, let me just quickly correct that, 254 Earths. Yeah, it has a mass of 254 Earths, or 254 times the mass of our Earth, while Kepler 90H has a mass of 382 Earths, which is quite a bit higher than our Jupiter. Now the other inner planets, the remaining 6 planets, as in yeah, these 3 planets over here. Now we have a rough estimates of their rough sizes, but we're not shown their exact mass. Now the 3 inner rocky planets are slightly larger than Earth at 1.31, 1.18 and 1.32 mass size of the Earth, as in radius. Let me just go to the first one. Just a moment. Go away. Okay, let me first go to Kepler 90b. It has a radius of 1.31 times that of the Earth, but we're not shown the exact mass. We just know the radius of it, which is 1.31 times that of the Earth, while Kepler 90c has a radius of 1.18 times that of the Earth, and then Kepler 90, 90I has a radius of 1.32 times that of the Earth. Now, these planets are quite close to their planet, to the star. Kepler 90H, for example, is about 1 AU from the star, 1 astronomical unit from the star, which means that basically it would be it's basically more or less the same distance that Earth is from our sun, from the sun. Basically about 150 million kilometers from the sun, from Kepler 90, which means that all the other 7 planets are within, between Kepler 90 H and the star, which is very tightly squashed together. How exactly this came about, we don't know yet. Perhaps some kind of strange planetary migration. We don't know yet how exactly they came about to be so squashed together. So the 3 inner rocky planets here are just slightly bigger than the Earth, up to 1.3 times the mass size of the Earth, and then the remaining other three, Kepler 90d, E, and F. Let me just go on the chart here again. These three planets over here, they're about more or less the same size as Uranus and Neptune in our own solar system, and they're also quite close to their host planet. Now, if I remember correctly, it was Kepler, no, not that one. Which one was it? Kepler 90I that they discovered recently, and where they made the announcement where they discovered this that this system has 8 planets. So yeah, now there's probably more planets that orbit the star, because our own solar system is also quite a bit larger than this one. Let me just give you a comparison. Neptune is, let me just give you a quick comparison of just how big our system is let me just get the distance right. Now, as you can see, Neptune's orbit is way out over here, while Kepler 90H is way over here, while Neptune is way out over, where is it now? Where is it now? Ah, man, I lost it. Where are you, Neptune? Where are you? Come on, where are you? Right over there. There's Neptune. So as you can see, there's a huge difference between Kepler 90H over here and Neptune over there. There's a distance of about 29 astronomical units, or AUs. 29 times 150 million is about 4.5 billion kilometers distance between these two planets. And that's about it for now. Just wanted to talk a little bit about this discovery, and let me just speed this up a little bit and see what will happen. You see, their orbits are relatively stable over long periods of time, so I just wanted to see quickly what would happen if I were to speed it up a little bit, if their orbits will remain stable for that long. Okay, so we are now at just over 1 month per second, and oh my gosh, the inner planets already, as you can see, already out of whack. The 3 inner planets here, they're already completely out of whack. Okay, let me just pause it here. Normally, if you have planets that are in orbital resonance, this should actually not happen. I think I actually got the distance a bit off, but in reality, these planets are actually in orbital resonance, which means that their orbits should actually be stable. So I actually made a mistake in placing their orbits correctly. Okay, I got their distance more or less correctly, but I guess I should place them to the exact kilometer. I was off by a few kilometers, but I guess that makes one heck of a difference. But now this planet Kepler 90c is now completely out of whack, and which is making the orbit now completely distorted. Now let's see about the other planets. Let's see if their orbits are stable, and it seems that maybe they are. It's just Kepler 90c that's a bit out of whack for now. Now the other three gas planets here, they seem to be in a relatively stable orbit. Kepler 90g and h seem to be in a stable orbit. It's just seeming to be the inner three planets that seem to be in, well, out of whack. Maybe they will collide, I don't know. Yeah, but whether there are other planets in this system, we'll have to find out. More research will have to be done to see if there are more planets in this system. It's possible, but for now, this is the largest solar system besides our own around another star worth 8 planets. Now there are, like I said before, there are several other stars that have like 5, 6 and even 7 planets, but this is now the first to have 8 planets, just like our own. And Kepler C is really having a bore with the orbit. But the gas planets, they seem to be in a relatively stable orbit. Yeah, and the temperature on Kepler C is varying wildly. Maybe sooner or later it will collide with one of the other two rocky planets, but yeah, I actually don't want to see and find out. So for now, this is it, and I will keep you guys posted on this kind of stuff. So if you want me to talk more about these kinds of solar systems, just let me know and I will let you know. Man, Kepler 90c's orbit is really changing a lot. First elongated, now more circular. Oh my gosh. Anyway guys, I will see you in a jiffy. Bye guys.